And I also agree with you, but I'm not as cynical about the state of affairs for a variety of reasons. 30 years ago, when Cosmos premiered on PBS, there was like 5 TV stations, right? That was it, kind of, right? Of course, there was no internet, no computers, no PCs, that is. And so you could go months surfing. The word wasn't in use back then. Getting up from your couch to change the channel of the television. You could go months before you would stumble upon science programming. Yes, there was the weekly Marlowe Perkins with the animals, and then the undersea guy, Jacques Cousteau. You had them. But that was it. You know this. That was it. So Cosmos represented sort of a breakthrough in access to the science frontier, a kind of singular breakthrough. Who would have thought back then, if I went up to you, because you're active producing the show, and there it is airing, I say, Ann, in 30 years, there's going to be an entire television station devoted to just science. I don't think you would believe me that that would even be possible. Other stations, not 100% devoted to science, but major portions of their portfolio given unto science. Even stations such as the History Channel, formerly known as the Hitler Channel, because that's all they showed, was World War II. And then they got hip to the fact that maybe science sells, maybe the cosmos sells. And they're on their 3rd season of the show called The Universe, that many of us in this program this week were actually interviewed for. And so access to science, however, whatever are the publishing challenges that exist in the science sections of the printed newspaper, I don't see any shortage of the coverage of science in the media, or in the media, or in broadcast media, in news media, or in cable or broadcast television. And so I'm a little more hopeful. Even though the state of affairs and the science literacy of the nation is low, embarrassingly low, scarily low, access to science is not. And so what we need is to establish the conduits to the cosmos that the nation can then grasp and then bathe in all the glory. That's what I mean. What?
What?
I have further evidence that we've come a long way, if I might. When I was in high school in New York City at the Bronx High School of Science, I've got one guy from the Bronx Science right here. We got one guy. Actually, that was Shelley Glashow. Actually went to the Bronx High School of Science, one of 7 Nobel laureates who were graduates of the Bronx High School of Science. And all in physics, I might add.
Didn't Brian Greene and Lisa Randall both go to Stuyvesant?
They went to Stuyvesant, yeah. But they did not win Nobel Prizes. Yeah. I'm just saying. I'm just saying. But that wasn't the point of what I was trying to say. I want to say that in my day, if you were a nerd, that was sort of a vilifiable title, a vilifiable label. And you'd get slammed into the lockers by the football players, and you couldn't get dates, and you were just not welcome into the rest of society. Until the rest of society learned that it's the nerd who can fix your computer. And so there came this economic force, and it's the nerd who could launch a brand new industry, a new economy of tomorrow. And so the nerd became actually kind of cool. And then the richest person in the world is the patron saint of nerds. We've got. And so there has been a phase shift in much of the community, much of the nation, about how you look at people who have this special kind of talent. And 30 years ago, that just simply was not the case. And so I see that as a very positive sign. Another point about the Kepler mission, Anne, back in the days of Voyager, you remember Voyager, the grand tour of the planets. In the day of Voyager, that was kind of the only thing going on in planetary science. It was a big story, spacecraft with enough energy to escape the solar system. and you would like attach all kinds of stuff to it for aliens to find. That was great. But heartbeats and songs and Chuck Berry and everything.
Right.
And you did it, right? And
right.
I want to just applaud that.
Thank you.
Okay.
Thanks.
It wasn't just put on any spacecraft, on the spacecraft that would leave the solar system and never come back. My point is, back then, that received a singularity of focus because that was sort of the biggest news of the solar system. But right now, we've got a mission to Pluto. We're in orbit around Saturn. We've got rovers on Mars, orbiters on Mars, spacecraft to Mercury, monitoring the sun. And so...
No, may I clarify something?
Okay, yes.
I
just want to say, so
No, first of all, I'm sorry. I will take a back seat to no one in terms of optimism.
I'd just like to add, not a moment goes by that I'm not conscious of the fact that Carl Sagan ventured into vistas not previously allowed in the scientific community. When he appeared on Johnny Carson, The Tonight Show, that was considered shocking by his peers.
And they mistreated him for it.
Yeah, you're a scientist and you're appearing on a late-night talk show. Are you out of your mind? You're writing for Parade magazine. Are you out of your mind? And so I don't, for a minute, take any of that for granted because he did it first. He did it better than anybody. And I and my colleagues are in this sort of cleared path behind him doing just that. And so I can say that while not enough of us in the scientific community, to your point earlier, Claudia, that public outreach is not rewarded in research science. It's simply not. At worst, I would hope that it was just neutral, all right? But in so many of the sciences, it's not neutral, it's actually a demerit. I can say, however, with some confidence, that in the astrophysics community, since we had Carl Sagan, whose some of his blood is on the tracks, and it came first, the rest of us saw the tide waters, the budget waters rise for our space missions in the presence of Carl's activities. And so, to this day, I can do what I do, and my astrophysics colleagues can do what I do without much fear, without it counting against us. And I credit that all to Carl, completely. So I just want to say, Ann, not a moment goes by without me recognizing that. I want to just thank you all back when you did that. Okay. I guess I don't know what I was saying. Let me try again. No, just briefly. I was trying to combine two thoughts, and maybe I did it imperfectly. I wanted to agree with Ann that one of the noblest causes for exploration is to more deeply understand our place in the universe. Not only the universe of the large, but the universe of the small. Our relationship to bacteria, to viruses, to the rest of the animal and plant kingdom, nature. And so that's just, one should do that just simply because it's a beautiful thing to do. But at the end of the day, scientists do not control budgets. Politicians control budgets. And in democratic societies, people elect politicians who control budgets. And so I submit to you that this resurgence of restoring science to the front of the agenda is not the consequence of people finally realizing how beautiful it is to discover science. My read of that landscape is that it's the consequence of people not wanting to die poor because they're recognizing the economic value of this investment. And so I'm applauding it, yes. You've got good folks up there. It's the Secretary of, the President's Science Advisor and the Secretary of Energy. These are talented people, both physicists, in fact. So that's cool, you know. So that's my bias there. Because physics is, of course, the foundation of chemistry, itself the foundation of biology. That's just the fact. That's just how that builds. So, and while I'm sort of dissing biologists, let me add that, no, I don't mean to diss biologists, but the notion that we discover cures for hepatitis and other things that might kill us, and the urge to fund this because it's the I don't want to die urge to fund, that keep in mind that the urge to triple the budget for the National Institutes of Health relative to NASA or the NSF or other drivers of the physical sciences, consider that you walk into a hospital, essentially every machine with an on-off switch invoked in the diagnosis of the human body without cutting it open has foundations based in some principle of physics. And so you cannot fund one without the other. All the frontiers of science need to happen simultaneously, and it's the unexpected cross-pollination that makes the revolutionary advances in our understanding of ourselves. I need to bring Lawrence to a new place, if I may.
Oh, wow.
Is it Mars?
Okay. No.
I'm slightly scared.
Lawrence, my distinguished colleague to my left, has a let me say, party line position of the scientific, many in the scientific community, that the MAN program is largely just a waste of money. That you take that same money, and for every chunk of money that you spent putting a human being wherever you were going to put them, you can send 100 unmanned probes.
1,000.
To go 1,000.
It's probably
somewhere between 100 and 1,000.
Yeah, it's
Factor
about
10, we're astronomers, it's fine.
Okay, so that is surely true, and I have no argument with that. But it assumes. It assumes that NASA is your private science funding agency. But the history of NASA's funding profile has never betrayed that fact. If you look at the fraction of NASA's budget over its 53-year life that has been given unto science, it will average at about 22% of the total budget. It peaked in 2004 at 40%. The recent average has been about a third. It has never been more than a half.
Human spaceflight.
The fraction of the total NASA budget given to science has never been more. The average has been down in the 20%. So what that says is NASA was never budgetarily driven by science motives. NASA, from its inception.
Oh, we don't know.
We don't want to talk about conception here.
NASA, from its inception, as Sir William, to my right, duly noted, was driven by Cold War politics. Let's be honest with ourselves about this. The very speech that we all remember and resonates in our cranium, President Kennedy saying, "We will put a man on the moon and return him safely to Earth." You can even hear his Brookline accent as he recites it in your memory. In Kennedy Space Center, Florida, there's a bust of Kennedy. And chiseled in the granite in the main entrance are those words. There's a lot of other granite there with nothing chiseled into it. What they could have done was put another sentence from that same speech, but they didn't. Here's a sentence from that speech. If the events of recent weeks, Yuri Gagarin had just come back out of orbit, and we did not yet have a vehicle that could safely put a human being anywhere off the launch pad. He said, if the events of recent weeks are any indication of the impact of this adventure of the minds of men, then we need to show the world the path of freedom over the path of tyranny. That was the battle cry against communism. That was the war driver. That's what dislodged the $100 billion from the American coffers to send us to the moon. Let us be honest with ourselves about that. The budget for NASA has always been historically driven by geopolitical forces. Given that fact, if you want to have the argument that it shouldn't be a geopolitical force, that's fine. But you cannot cry foul because it's not science. That's apples and oranges.
Mars Phoenix.
No,
it tweeted itself as a little person and was fallen in love with, and when it died, it was immortalized in Wired magazine by people who cried at the death of a Twitter feed that died with a robot.
But, you know, I think...
Wait, that's delusional. I'll explain why.
I agree.
Okay, Neil, go ahead. I'll speak later.
Allow me to explain.
Okay.
The reason why there's so much interest in that Twitter feed is because the manned program was not itself advancing an exploration frontier. Had they been doing that at the same time, no one would have given a rat's ass what the robot was doing. And that's what was implicitly recounted here with the moon. in the 1960s, there were robots on the moon. Did you hear about any of them? No, because the manned program was advancing a space frontier. If you do both simultaneously, we're going to be listening to the tweets of the astronauts and not of your robot. That's how that happened. Without the manned program, the robots look really sexy.
I hate to agree with Neil at all, but
Sorry, should I just calm down?
No, bring it on, Dr. T.
Here's the Prozac.
Testify.
Plus, we got questions.
Tell the truth.
And I want to make sure we get the questions, but I got to rebut that. Rebut that. Okay. To say there's no budget in the world, the federal budget is $3-point-something trillion.
Doesn't go as far as it used to.
If you...
yeah, it used to be real money.
If you want to count to 1 trillion, it would take you 100,000 years, and that's one number per second every waking and sleeping moment of your life. That's how big that number is, point one. Point two, it's not that we can't afford it, it's that we have chosen to not afford it. I tweeted recently, exceeded the 50-year budget of NASA. You want to put something in context. If you want to do something with $3.5 trillion, you can do whatever you want. Whatever you judge to be important to the profile of the nation that you were trying to build and to sustain. So I submit to you that when you look at the NASA budget, and I'm tired of saying this, but I'll have to say it again, the NASA budget is 0.4 of 1 penny on a tax dollar. If I held up the tax dollar and I cut horizontally into it 0.4 of 1% of its width, it doesn't even get you into the ink. So I will not accept a statement that says we can't afford it.
I gotta say, that's Dr. T.
Let's just give my favorite mission, which doesn't exist and isn't funded now, but it'd be really cool.
Yes.
It would be to go to Jupiter's moon, Europa, which has an icy outer surface. The gravitational stress on Europa from Jupiter and other surrounding moons is pumping energy into it, much the same way when you warm up a racquetball by hitting it. You distort it, it bounces back to shape, you're pumping energy into it. That has melted the interior ice. It has had an ocean of liquid water that's been liquid for billions of years, and every place on Earth we find liquid water, we have found life. I want to go ice fishing on Europa, put lower submersible, look around, and for me, the biggest question will be, what do you call that life? It'd have to be like Europeans, right? Because it's Europa. That's what I think.
Europanians.
Well, I think we should go a lightning round here, where only one of us can answer. We have to answer it quickly so we can get through everybody. How about
you want to talk about dreaming an impossible dream? We're not going to get to everybody, but we're going to have one more good one here.
Do you think the concept of a space elevator is possible, and if when?
No. Next.
No.
But bear in mind that the space elevator is this thing that's so strong for its weight, you could just take an elevator into space. But once again, the political problems are going to be the hard thing. You know, if the thing comes loose and starts whipping around, and then who's going to build and who's going to be responsible, the ultimate high ground and all that stuff. But
plus, you might use it to drill into the Earth and drop a black hole.
Okay, next question.
One more here.
Anyway,
one more.
Yeah, and those materials will change the world.
I knew it.
But I have to rebut Larry here. Lawrence.
Yeah, thank you.
Lawrence.
Neil, make it short because our keynote speaker is a real diva. So I don't want to eat into his time. Because you know what he's like. So real short. Here we go.
It's real short. I'm guessing, Lawrence, maybe I'm wrong, but I'm just guessing that whatever it takes to terraform Mars and move 1 billion people there so that we're a multi-planet species, so that one planet does not go extinct from an asteroid, whatever effort that is, that's probably more than what it takes to deflect an asteroid. By virtue of these asteroids, estimates are something like 95, 96% of all species of life there ever was are now extinct. That is not the signature of a planet that embraces life. That's what a planet does when it's doing all it can to kill you. That's Earth. Now, of course, I'd rather live on Earth than on Venus, where you would vaporize in 20 seconds, okay? So, all things considered, I'd rather be on Earth. But don't run around and say that Earth is nice to us, because it is so not. Earth might not be the origin of life. It's hard to assess what the likelihood of this is, but it's certainly plausible. There's something called panspermia. Panspermia. So here's how it works. If you do the models of the formation of the solar system, all evidence shows that Mars had running water before Earth did. Right? So put a little check in that box. Earth, running water before Earth. 2, early solar system, there was a lot of impacts, leftovers from the formation of planets, still accreting to make the planets themselves. We have learned from computer models that if you have a strong enough impact, it can fling surrounding rocks into interplanetary space. It can fling them. One way to try that is you can sprinkle Cheerios on the bed. And then take your hand and slap it in the middle of the bed. Cheerios will go upwards, achieving escape velocity from the bed. Okay? This is a similar sort of wave flinging phenomenon. Now, on Earth, we have found branches of the tree of life, microbes, that thrive under conditions that would kill us. Kill us. We call them extremophiles. Some of them can be freeze-dried and reconstituted later. Some of them survive very high sort of radiation. I mean, they're hardy, okay? You suspended animation, high pressure, low pressure, high temperature, low temperature. These are conditions under which certain branches of bacteria thrive. You can, like I said, you can freeze dry them, high radiation, high acid. That's on Earth. If such bacteria started on Mars and got caught in the nook or the cranny of a rock that got flung into space, then that rock would move through space and later on land on Earth, seeding Earth with microbes whose point of origin was Mars. We did the calculation. There's several tons of Mars rocks here on Earth, not yet collected from the meteorite supplies. All right? So you can calculate how much stuff is moving from planet to planet. Get a stowaway microbe. We may be descendants of Martians. Some people perhaps more so than others, and evidence may point to. Now, there's a photo that I just got from NASA. You know, we have a new rover there. This is still classified, actually. I smuggled this out from the NASA headquarters. So this is the very first picture taken by the rover from Mars. Right there. It's classified. Doesn't leave this room. $99 billion in one. We're all Martians. Well, what about life? You know the number one molecule in the human body? Someone said hydrogen. Water. Water, thank you. Who said hydrogen? Who said hydrogen? Stand up. Who said hydrogen? Let yourself be known. Hydrogen, a pure element. We'll get to the elements in a minute. The number one molecule in the human body is water. We're like 60% water, something like that. Now, in terms of the atoms that are in us, hydrogen is very high on that list. But we never say that we're hydrogen-based life. We are, in fact, carbon-based life. Carbon. Carbon is the foundation of life as we know it. Why? Carbon is the stickiest element on the entire periodic table. It combines with elements every which way. I once interviewed Jon Stewart for my radio show, Star Talk Radio, and that's when I learned he majored in chemistry when he was in college. You know that? Then he switched to psychology later on. So I asked him the geeky question, do you have a favorite element? He said, yep. I said, what was it? He said, carbon. Now, I know why carbon is like my favorite, but I want to get his reason why it's his favorite. I said, why is carbon your favorite element? He said, because it's the slut of the periodic table. It combines every way you want. So that was like comedically deep, right? I mean, he had insight into carbon. You can make more molecules with carbon than you can other kinds of molecules that don't have carbon combined. In other words, make a list of all possible molecules without carbon. You can make more molecules with carbon than that list. So, if there is a chemistry on which you want to base the diversity of life, and you're picking elements off the periodic table, carbon is your element. Carbon. Not only that, carbon is plentiful. It is plentiful. Forcing you to ask, would carbon be the foundation of life as we don't know it? It doesn't have to be. There's many science fiction episodes that talk about silicon-based life. That's another element that forms in a lot of the same, forms molecules in a lot of the same way carbon does. You don't need to appeal to silicon because there's 5 times as much carbon in the universe as silicon. Plus, silicon makes bonds that are very hard to break. Silicon is like the active ingredient in rocks. We are carbon-based life. Well, what does that mean? Let's look at the abundance of elements in the universe. You can rank them. Let's rank them. The universe itself. Number 1 atom in the universe, hydrogen. Number 2 atom in the universe, helium. Number 3, oxygen. 4, carbon. 5, nitrogen. And my favorite element of them all, other. Okay. Now, how about life on Earth? Life on Earth. Let's find out. Number 1 element in life on Earth, hydrogen. Number 2, well, is it going to be helium? No, it's not going to be helium. Why? Yeah, helium doesn't react. It's inert. It's on the right-hand column of the periodic table. All of those elements are called what, remember? The noble gases. Do you know why they're called noble gases? I'm going to tell you, the Brits. Now watch. Here's what happened. The British, who discovered most of those elements on the right-hand side of the periodic table, noticed that these elements do not commingle with any others. And who in British culture do not commingle with anyone else? It's the noble class. So their asinine caste system ended up in our periodic table of elements, reminding me why we fought a war to get the hell out of there. Excuse my language. And we're stuck with it. The noble gases. What they didn't know is the noble gases don't even combine with each other. All right, they missed that part in their labeling of it. So helium, you can't do it. Helium, you can't. You could breathe it and sound like Mickey Mouse. That's about it. That's all you can do with helium. So, no, it is not next. It's not, okay? But you know what is next? Oxygen. And the hydrogen and oxygen give us what in our body? Water, there you go. Next to the human body, carbon. Next, nitrogen. Next, other. Thank you. So, we are one for one, the ingredients of the universe. If we were made of some exotic elements, like an isotope of bismuth, then you'd have an argument. You could say life on Earth is rare. It's got to be unique because the ingredients are so unusual. It's like 1 in a zillion that you could put these ingredients together that way because they hardly exist in the universe. We're made of the most common stuff there is. Thank you for that warm welcome. It's good to be back in this visit to San Francisco. I'm told the sun was out a couple of days ago. Is that right? The rain is, plants need rain more than we do. Thanks for coming out for this. I'm here to just kind of talk about the universe, but through the lens, I'm restricted to the universe in my subject matter. In Death by Black Hole, first, I couldn't resist that title. There's a chapter in here with that title, and that chapter bears that title because it's a complete discussion of how you die when you fall into a black hole. And when I think of black holes, I think of sort of the adult counterpart to what, as a kid, would be T-Rex, because every kid loves T-Rex. But why do they love T-Rex? It's because T-Rex can eat the kid, all right? And you tend to have a deep respect for things that can eat you. So black holes, when you come too close to them, weird things happen to your body. And I'll get back to that in just a few minutes. I'm not going to read from the book because you can just get the book and read the book yourself. So presumably you came to hear me say something differently enlightening or even relatedly enlightening to what's in the book. And so what I'm going to do is, I looked at the book as then I'll just kind of give you some summary points of those chapters, okay? And then, so this will be a sampling of the science that titillates me, but also this collection is the science that has been most requested by the public. Even if I didn't think it was interesting, the public thought it was interesting. I said, well, let me find out why. And part of it was this black hole thing. Everybody wants to know about black holes. If I'm on the plane and someone sees I'm reading some astrophysics literature, say, what do you do? I do astrophysics. First question is, tell me about black holes. Then maybe Search for Life and Big Bang. And I'm trying to think, well, suppose I said I was like, you know, nuclear chemist or particle physicist. That would just end the conversation right there. But they find that I study the universe, and it becomes this very engaged conversation. So there's this appetite for cosmic content for which I see myself as a servant of public interest. And so the material that's in here is the blending of aspects of the universe that I want to bring you to, and aspects of the universe for which I know the public has a deep curiosity to learn more about. And so that's how that goes. And let me lead off with the following datum. There's about 6,500 astrophysicists in the world. It's not very many, actually. It's just, a few thousand. And there's about 6.5 billion people in the world. So if you divide those two numbers, you get 1 in a million. So, no, what I mean, now the point of that exercise is, if you ever find yourself in the company of an astrophysicist, that's your chance to ask the question. Because you never know when that's going to happen again. That's just advice, okay? And I think that's why, like I said, I'm on the airplane, that people just bust out with questions. Like they've got some question center within them, and it's building up, then they're ready to explode, and the whole rest of, so, that's just so you know. Okay, here we go. What I try to do here is connect the reader to the universe in a way that allows you to become a participant in the machinery of the cosmos. So I like to think of this book as your way to go around the back door and lift the hatch and see the gears turning and the oil box and the pulleys and the levers and all the things that allow you to understand not simply what's in the universe, but how the universe works. And in that way, you're empowered to have fresh thoughts about what's going on, rather than just repeat the factual information you'd otherwise get. That's the goal of this book. Okay? And I invite you to share in that goal if, in fact, you value that level of intellectual diversions in what is otherwise your workday. So I've got a chapter called Coming to Our Senses. And I'm told I have like half an hour or something, right? Is that about a half hour? I'm happy to do that. All I want, okay. I'll give you a late pass when you go back to work, okay, if you need. Coming to our senses. There's a whole chapter called Coming to Your Senses. And what that is, you know we've got 5 senses, right? Touch, taste, smell, taste, sight, hearing, thank you. 5 senses. And then occasionally you get the person who comes up to you and says, I have a 6th sense, okay? These are people who claim to know stuff that they wouldn't otherwise know, typically. It turns out if you take those people and put them in the laboratory, the 6th sense just simply goes away under controlled circumstances. So either the 6th sense is this shy thing that doesn't lend itself to investigation, or it just doesn't exist at all, and we've duped ourselves into believing you had this power. But what I want to share with you is the fact that modern science, beginning 20th century, began to invent apparatus that would measure things that are completely outside of your 5 senses. No capacity to measure it whatsoever. So that, in fact, modern science has multiple senses, dozens of senses. So you want to ask, you have a 6th sense? Here's some things you can't measure. For example, the magnetic field in this room. The human body has no capacity to measure the strength of a magnetic field. The human body has no strength to measure whether we are being bombarded by ionizing radiation. You'd eventually figure that out as your limbs fell off, you know, as you'd come to learn that this was the case. But while it was happening, you would have no idea. We don't have high-energy radiation detectors built into our system. We've got detectors that can do it. So if there's something emitting ionizing radiation anywhere around, we'd be able to find it. I call that a sense, another kind of sense. Now, not only can we go outside of our 5 senses, we can vastly improve the 5 senses we have. And so what science is about, of course, is advancing our capacity to intersect with the cosmos. That's what science is. So that's what a microscope does. You see smaller things that you never know. The telescope, see farther away. Particle accelerator. All of this are simply ways to enhance and extend and invent beyond our 5 senses. The simplest ones among these are, you know, this visible light, Roy G. Biv, right? You know Roy G. Biv, remember him? Red, orange, yellow, green, blue, indigo, violet. There's really only 6 colors there, but Isaac Newton, who first labeled these, he had a fascination with the number 7. And he came up with 6 colors. I got to put in a 7th one. And so he slipped in indigo there. Doesn't belong there at all, but he slipped it in. If you're going to put in indigo, you might have put in 7 other colors, have 14 colors in the spectrum if you're going to be that specific. Indigo is this narrow segment between the blue and the violet. It doesn't, in that scheme, deserve its own color name, unless you're going to have way more than 7 to label. But that's neither here nor there. So those are the colors, and we define that as visible light, but light goes far beyond each side of that spectrum. You go beyond violet, you get ultraviolet. You go the other side of red, you get infrared. And you keep going in each direction, so violet, ultraviolet, X-rays, gamma rays, red, infrared, microwaves, radio waves. All of this is light. It all travels at the speed of light, and we had no telescopes capable of observing outside of the visible spectrum until 1920, and that was a very crude telescope itself. And we didn't start really getting data on this until the 1950s and 60s. So we were practically blind to the universe before 50 years ago, thinking that our eyes were somehow the true measure of what's out there. So all of our detectors and telescopes were extensions of our eyes and not probes into whole other branches of what we call the electromagnetic spectrum. Good evening. Thanks for that warm welcome. Normally you save that for the end so that I earn it. Okay, I just want to earn that from you. The sun came out today. I thought that was kind of interesting. In fact, I might tweet that right now, if I may. So let's go ahead and do that. Okay? So I have a tweet ready to go there. Let's see. In Seattle now, the sun came out today and people reacted joyously. Must be a rare event. Okay. 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 So we'll check back in on that later, why don't we? And let's get back to, am I there? Now, what I'm really going to do, this is really a talk on the musings of an astrophysicist. That's really what's going on here. I mean, this lecture might not even be coherent, because I'm just spilling out perspectives on things, just scattering them into the wind for you to receive, okay? So there's a little bit of everything tonight. I hope you don't mind. Now, often talks like this are just sort of loosely veiled commercials for some book somebody's going to sell. But this was no exception to that. No, actually, no, I don't like giving book talks because you can just read the book. If I'm there in person, I might as well talk about something you can't get from a book. So some of what I'll be talking about is in books, but the collection of it all together, you're not getting anywhere except here and now. So let's just start. So we're going to do some science up front, but then we're going to take you to new places, all right? In the search for life, you know, what we're doing is we're trying to find the water. And we know there's water on Earth, and there's life everywhere on Earth where there's water. There's life, even the Dead Sea. The fact that it's called the Dead Sea is an example of what you say when you don't have a microscope. Okay, so this is just how that was. Mars, there are microbes doing just fine in the Dead Sea. Mars, Europa, one of the moons of Jupiter, exoplanets. So our search for life is driven by the search for water. Europa is one of the moons of Jupiter where we're pretty sure there's an ocean, a liquid ocean of water beneath a frozen surface. So one day I want to go ice fishing on Europa, cut a hole, check out, see what swims up to the camera lens. You know what I like about Europa? Suppose we do find life. Then what do you call it? Call it Europeans, you see? that's what else would you call it? Let's go to Mars. We've seen Mars before. There's a nice shot of Mars. Can people hear me up on the top? Up in the cheap seats up there? You guys okay? You're all up there? Okay. Mars. You know, Mars is intriguing because it rotates once in about 24 hours. It's tipped on its axis, so it has seasons. It's got polar ice caps. It gets everybody excited, especially this fellow, looking quite tweedy there. Percival Lowell, a wealthy New Englander, who was wealthy enough to just sort of build his own observatory, and he called it the Lowell Observatory, yeah. Put it in Arizona, and he was really liked Mars, and he was pretty sure life was thriving on Mars. So he wrote several books. This was his first. And you look in these books and you find diagrams like this. And he called these canals, which was a mistranslation of canales in Italian, which meant channels. but he was wealthy, but he didn't know Italian. And so he thought the people who thought they saw channels, he thought they meant canals, and if it's a canal, it means it's artificially made. So this is what he saw when he looked through his telescope that he made and put in his observatory. Now, we know that none of these canals are there, and there aren't these cities. He was imagining life forms were going extinct, and they would channel water from the poles into the cities, and it was catching them right at the end of their civilization. So this is not the first crazy thing he did. But anyway, in modern times, we actually go there. Yeah, so there we've got one of the rovers. We went there before the rovers. You might know that. We went there back in the 70s. Two Viking, they were called Vikings, one landed, one orbited. And the orbiter took this photo. That's a good one. Ooh, oh, ooh, ooh. Yeah, that's better music here. The face on Mars. Da, 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 da. So everybody got excited. Well, sorry, not everybody. Those people who were sure that life on Mars had a simian face, okay? I mean, think about it. Most life on Earth does not have a simian face. Most life on Earth doesn't have a face, all right? So life with which we have DNA in common. All life on Earth has DNA in common. Now you're going to go to another planet and it has a face. The only things on Earth that have faces are like vertebrates have faces. That's a vertebrate face. So you want to say that there are vertebrates on Mars and they're simian in their biology. Well, there's only one thing that looks like a face, no matter the camera angle. And what is that? A face, yes. So we go back at another time, and this is what it is at another time with higher resolution. It looks less like a face. You can kind of see how it might have been. Now, all the Mars fanatics said, oh, the Martians figured out we were looking at them, and they quickly covered up the monument. Then you go back again, and it's like even less like a face. So the Martians have continued to cover this up, apparently. So more on that later. But in fact, I do have the first evidence from the rovers. This photo, in fact, has been kept from the public till I have special connections to NASA, as you heard in the introduction. So this one was the first image taken by the rovers, and it's been suppressed by NASA ever since. Right. So I thought I'd share it with you guys because, like, you know, you're my people tonight here. By the way, if you're looking on Mars for faces, why not look for other things that are familiar? You know, you only see that as a face because we have a face. And familiar things are what you pick out, even if they're not really there, right? When you look up in the clouds, you don't say, oh, I see a lobster. No. Has anyone ever said they see a lobster? No, you say, I see Abe Lincoln or George Washington. You're looking at sort of familiar iconography of our culture. And so let's find some more familiar iconography in the Martian terrain. There's the Valentine crater. There you go. We got one of those. How about the smiley face crater, right? So if you look hard enough, you can find stuff and call it whatever you want. So, but Mars, one thing is certain. It's long suspected, but recently confirmed, that water, while not on the Martian surface, is beneath the surface and not very far beneath. This is a crater about the size of this stage that was freshly left in the photo on the left side of the image here. And if there's water beneath the surface and an impactor comes and an asteroid hits and it makes a crater, that crater is, like I said, about the size of this stage, it will lay bare any water that happened to be beneath the surface. That water would melt on impact and then instantly freeze, and then there you get it, right there. You see the frozen sort of surface area there. Now you might say, well, suppose that's just chalk or some white rock. Maybe it's not really water. Well, you come back a few weeks later and it's basically evaporated. The official word for that would be to sublime, if you're into accurate chemistry vernacular. And so the point here is the evidence that water is beneath the surface remains manifest in many ways. And here's one where you see rivulets and a flood puddle over to the side. I mean, this is just, they're meandering riverbeds and river deltas, all of the telltale signs of water carvings that you fly over when you cross the Midwest in a plane. You see that on Mars. So definitely water's there. So water's good because maybe there was once life, but also water gives you energy. Did you know that the orange tank of the space shuttle has 2 tanks within it, one twice as large as the other? The big one contains hydrogen, the little one contains oxygen. You bring them together, the exhaust of that tank is H2O, otherwise known as water, and that is the very simple chemical formula for what's going on at the bottom, at the business end of the space shuttle.
Thank you both for being here today. I was just going to ask, because you recommended that we expand the vocabulary of astronomy to include planetoids and all that stuff. And if you do that, won't you get away from the whole idea that you know, astronomy is full of these simple words? And wouldn't it make it harder for third graders to understand it and really appreciate it and write letters?
That's an excellent question. It goes 2 ways. If there aren't many objects, then you can just make up fun words for them that are sensible and you just stick with that. The moment you have objects beyond what can be sensibly named, then you have to go into a more formal classification scheme. Our stars, for example, are classified in a slightly arcane way, but precisely, with high precision. And so the sun, for example, whether or not you knew this, is a capital letter G, Arabic numeral 2, Roman numeral 5. Okay? G25, that's what it's called. And so it's a G star. So each of those things means something, okay, for its class. And we needed that because the stars were coming in at us from every direction. And so the stars are lettered. There's any one of 8 letters that they can have, and their numbers, subcategories of those letters, and then the Roman numerals can go 1 through 7. And so it gets arcane, and that removes some of the romance. But I can tell you that some of the brighter stars in the night sky still have regular names. If you look in a journal, we're not going to call the brightest star in the night sky Sirius. We're not going to use that designation for it. We'll stick to the romantic labels that they've had from antiquity. So it may be, the day will come, that solar systems and their contents have enough diversity that we'll need a more formal, less romantic scheme. And you're right, it'll become less accessible in that way to elementary schoolers. So you pick some of those things that are just fun, like what's dense like a rock, or big and bulbous like beach balls, and you bring in a beach ball and a rock. You know, you pick and choose, and you can still do that. I'm not going to require they learn everything in 3rd grade, but let them learn some actual science and not think that memorizing planets in order from the sun with a mnemonic is science.
Well, we have time for just 2 more questions, and I see this gentleman in the front has had his hand up for a while.
Thank you for coming. I like the characters that you play on Nova Science Now. Can you tell us if you have an opinion or any thoughts on CERN and the LHC and what it's going to be bringing to us?
Indeed, the LHC, the Large Hadron Collider, is currently the most powerful particle accelerator in the world. That might have been in Texas, but Congress voted to cancel the superconducting super collider that the physicists had proposed. By the way, had astronomers proposed that, we would have called it the super duper collider. See, that's what we would have done. Another one is the physicists are in Congress, you know, defending the budget that this would require, because Congress initially agreed earlier in the 80s, and they got cut as we sort of exited the 80s when the budget flinched. What else happened at the end of the 80s? Oh, I know. The Cold War ended. Oh. Physicists had, you know, wore shiny badges during the Cold War because physicists won the Second World War with their weapons. And so the value of physics as a defense investment was manifest. Without defense, voting $30 billion just to discover a new particle wasn't going to fly, it turns out. And so there's the physicist in the room, and I forgot whether it was in the Senate or the House, but they're getting questioned on what this would discover. This is the accelerator in America, and I'll get to the LHC in a minute, but this is an important story. And so they're asked, so doctor, will this accelerator, will it see the face of God? And the physicist said, Senator, it will see the Higgs boson. That's the particle they're looking for. And I think astronomer would have had a better answer for that, I think. There are ways to get that one out without sort of compromising your principles. So we could recommend, for example, I heard Michio Kaku mention this, a friend of mine back in New York, a physicist. What you could have said then is, Senator, whatever is your concept of God, this particle accelerator will bring you closer to it. They might have still gotten funding, okay? They might have. So, we don't have it. The center of mass of particle physics is no longer in America, it's in Europe. That's the thing about science. Anybody can do it if you have the vision and the resources. Large Hadron Collider is going to sample the states of matter that have never been sampled at the higher energies than have ever been sampled before. And the higher the energies you go, the closer back in time your cavity will look like the Big Bang, okay? Because the Big Bang was a time when the whole universe was small, under conditions of pressure and temperature that they're recreating inside this accelerator. Do you remember what the big fear was?
And still
the black hole.
Oh yeah,
apparently.
it's still out there.
Going to make a black hole, and it was going to eat the Earth. And it turns out we get bombarded by high-energy particles daily that dwarf the energies created in this. Nature is a much bigger particle accelerator than anything our hardware can produce. And these particles would have surely turned Earth into a black hole long ago. That's number one. Number two, I don't know if you checked this, but the week the LHC was turned on, that was the same week of Wall Street collapse. And the financial market collapsed. So I think the black hole went to Wall Street is what happened. Sucked all the money out of the economy. That's what happened there. So it's a tremendous international collaboration. And the black holes, people fear frontiers of physics. They've done it ever since the atom was first split. So people's concerns don't surprise me. It's our goal to make sure people are scientifically literate, and so that they can make an informed decision about information that comes across your newspaper headlines.
Our last question in the back.
You're the last one, so it better be like the best question ever.
Yeah, but no pressure.
I'll try. I have a list given to me by my daughter.
Okay.
What's the most shocking thing you've ever discovered about space?
Most shocking thing. Space in general or the universe? Because when you say space, I'm thinking empty space. Oh, the universe. Oh, most shocking thing? I'd say the most shocking and most seductive thing about the universe is that 85% of all the gravity we measure in the universe is traceable to something about which we know nothing. And we call it dark matter. We don't know what it is. We don't know. We have never seen it except for its gravity. We are dumb stupid about what this stuff is, but we know it's there. And that's 85% of all the gravity we've ever measured in the universe is traceable to that. And okay, I got used to that. And then who ordered up the following? That now you look at the expanding universe and you find out it's accelerating. There's some anti-gravity pressure that's making the universe expand faster than the natural other forces would have it behave. We don't know what's causing that either. That's called dark energy. And dark energy is 94% of all the matter energy in the universe. So all the science, everything we ever talk about is contained within 4% of what the universe is. And so there's a lot to learn out there, and which brings to mind the famous comment about cosmic discovery that the greater is your area of knowledge. As your area of knowledge grows, so too does your perimeter of ignorance.
Well, that's a beautiful thought to end on. Okay. I think we can't go further than that. Thank you very much, Neil.
Thank you. Thank you.